Hi once again. This video is a demonstration of how a question can be solved using the various trigonometric ratio as well as Pythagoras theorem, and also explore angles of elevation and angles of depreciation. In example 13, the diagram shows two horizontal triangular views ABC and ACD. Given that DAB is a straight line, AC equals to 65 meters, AD equals to 84 meters, angle CAB is 60 degrees, angle ABC is equals to 72 degrees. Let us calculate a few lengths and angles from with the question. Now, let me just copy the diagram over into a Word document. Alright, and then I'll use this Word document to actually demonstrate how this question can be solved. Now, part A1 says calculate, correct to three significant figures, the length of the hatch BC. All right, the length of the hatch BC means we are looking at this one. Hatch BC, this length here. All right, to calculate the length of the BC, of course, in subsequent topics in trigonometry, you will actually learn how to deal with non-right angle triangle. But for the context of this chapter, I am going to use the right angle triangle to demonstrate how we can calculate BC for a question like this. Now, if you look at the hatch BC, all right, it's got an angle near to it, 72 degrees. And like I mentioned, I am going to use right angle triangles. So let me draw a perpendicular line downwards in the triangle ABC. And if I want to calculate the length BC, all right, to make it a right angle triangle, I'll probably be dealing with BPC. But just BPC alone is insufficient because we've only got one angles out of the three angles and the three sides. So I will need at least another side or another angle to deal with this. Now, knowing the three angles is also insufficient because we've got none of the sides to begin with. So I am going to calculate the length PC before I actually start to calculate BC. Then what and how is the length PC going to be like? Now, if I don't focus on the triangle BPC, but instead focus on this blue triangle here, the triangle APC. From triangle APC, all right, we can see that we can actually calculate PC by giving it making use of the 65 meters and the 60 degrees over there. Now, if I use 60 degree as my reference angle, the length PC essentially is the opposite. All right, and then the 65 meters there will be the hypotenuse. So opposite and hypotenuse, I can actually link it with the ratio sign. So I'm going to calculate, all right, sine 60 degrees, all right, is equivalent to opposite, which is PC in this case, over hypotenuse, which is 65 in this case. Now I know then, therefore, PC is equal to 65 times sine 60 degree, and that will give me 56.2916, so on and so forth. All right, I'm not going to round the answer off since that's not my final answer. I'm going to make sure that I don't keep rounding off every single working step and then I end up with a super rounded off answer. So let's keep PC in its original state of 56.2916 and go calculate now BC. So if I go back and look at my yellow triangle in this case then, all right, my yellow triangle over there, I now know PC. With reference to the one and only angle there, 72, all right, PC is the opposite. And since BC is the one that I want to find, BC is the hypotenuse. Therefore, if I want to calculate my BC with the angle 72 as my reference angle, I have the opposite and I have the hypotenuse. Therefore, I'm going to use sine 72 degrees in this case. And I'm going to form my trigo ratio. Its opposite, which is PC, over hypotenuse, which is something I do not know. So I know that now my BC is multiplied by sine 72 is equal to my PC. Therefore, to calculate BC, I know it is PC divided by sine 72 degrees. Go and work out in your calculator. Take 56.2916 over sine 72. You should get the answer 59.1885, so on and so forth. And since this is the final answer that I'm asked to find, BC, I am going to round off to 3 significant figure, which gives me 59.2 meters in 3 SF. Alright, that is part A1 for you. Looks complicated, but actually not if you follow through with the trigger ratio that you want. And in order for you to find the trigger ratio that you want, you have to note what sides do you actually have or what angles do you actually have. Now let's look at part A2 then. Alright, part A2 wants you to find the area of triangle ACD. Let me erase what I have here. Triangle ACD, which is actually this green triangle here. Alright? Well, looking at it, again, I do not actually have the right angle triangle immediately. Alright, then I know formula is half base height. If I deal with the base at 64, what is my height then? My height goes back to what we have calculated so far, just now earlier at PC. Alright, I know my base is 84. I have calculated PC earlier. So to calculate area of triangle, ACD, area of triangle ACD is as good as using half my base, and then my height is PC, which is actually 56.2916, so on and so forth. Notice I do not use my rounded off figure. I actually use the full figure. I actually stored it in my calculator for calculation purpose. So if I were to calculate, this gives me 2,364.249, so on and so forth. Question wants me to leave my answer in 3 significant figure. So this is my 4th figure, and it decides to round down instead. Alright? That's part 1 and part 2 for you. Now let's take a look at part 3. And perhaps I should bring the diagram down. In part length of the hedge CD. Alright, to find the length of the hedge CD, which is actually this yellow long distance we have there. Since we have not done non-right angle triangle, let us try to figure things out with the right angle triangle. So over there, I know I have to find CD. I have the height PC here, which gives me a right angle triangle somewhere nearby though. Alright, so if I know the length of PD, alright, if I know the length of PD, I will be able to actually calculate CD using Pythagoras theorem, because if I have 2 sides, finding the 3rd side is not a difficult task. But how to find PD then? We know DA, alright, but what is missing is the AP. So let's go find AP. If AP, I refer back to the small triangle here, which we were talking about in part 1, I can see that actually I can find the length AP with the reference angle of 60 degrees and the hypotenuse at 65. Question is, can I use PC? Yes. However, this is strongly discouraged because if your PC is calculated wrongly, then your PA will be wrong, and then of course there's a rippling effect there. So in A part 3, let me first go calculate PA. To calculate PA, with the reference angle of 60 degrees, this is my adjacent. This is my hypotenuse. So therefore, I will then use the ratio cosine 60 degree is actually equals to adjacent over hypotenuse, which is 65. So to calculate AP, I know it is 65 times cosine 60 degrees, and that's actually 32.5 meters exactly. Now that I know what is AP, I can actually find out my PD. My PD, therefore, will then be 84 plus 32.5 meters, right, plus 32.5 meters. So that will give me a total of 116.5 meters. With PD now, with PC that was calculated earlier, we can therefore use Pythagoras theorem. I will know therefore that CD square is equals to PC square plus PD square, which gives me 56.2916 square plus 116.5 square. CD square is 16,000. Alright, if you go calculate in the calculator, alright, CD square is 16,741. Therefore, CD is actually 129.387, an irrational number, and we know we only accept the positive. Alright, because we know CD square, when you square root it, you get plus minus 129.387, but I'm only going to accept the positive because it is a measurement, it is a length. And in 3SF, CD itself is 129 meters as your answer. In part 4, question asks to calculate the shortest distance from C to DB. So let me highlight DB. DB is this red or pink horizontal line you have. They want the shortest distance of C to this entire line DB. Alright, the shortest distance is always the nearest distance. The nearest distance is always formed when it is 90 degrees, when in two-dimensional, that C is perpendicular to DB. This we have explored in the earlier questions. So we have calculated earlier, essentially the shortest distance, alright, is that PC in the diagram, the green line, or rather the green highlighted dotted line. So hence, alright, in part 4, part 4, the shortest distance from C to DB is actually the PC in the diagram. Alright, which is also your 56.2916, so on and so forth. And in 3SF, this time around, you can summarize, you can round off because it's the final answer. It's 56.3 meters in 3SF. And that's part 4.